All right. First one, construct a tangent line. How many times does the tangent hit the circle? Once. Don't draw it in. So somehow you guys with your compass and straight edge are going to get one of those right now. And how you're going to do it is you're going to use a circle theorem. Center. What if I draw a line from the center to point P? What did I just draw? A radius. And what's the theorem we've been working with? If I draw it to the point of tangency, it should be perpendicular. That's what you're going to do right now. All right, you're going to draw the radius in. And somehow, and you guys know how to do it already, we've done it a ton, is make a line perpendicular to your radius but going through P. Make a line perpendicular to your radius but going through P. So I'll just give everyone a little hint here. The radius itself isn't going to do it. I'm going to have to extend it out a little bit more. And I'm going to let you guys teach me how to do this. This is one of our main constructions we've relied on all year. How do I make a line perpendicular to the radius but going through P? Where are you going to put your compass point to start? On P. Put your compass point on P. And what are you going to do now when you make an arc? What's your arc have to do? Intersect the radius twice. That's why we extended it. It can go above or below. It does not matter. Now where? Go to either point of intersection on the radius. And again, you can open or close your compass from here. Go to either point of intersection. Make two more arcs. And then when you're ready, grab the straight edge and draw in a tangent line. A tangent line. And again, that line is guaranteed to be tangent because what's the radius? We've guaranteed by our construction that that radius is perpendicular to that line, so that must be a tangent line. Must be a tangent line. Not bad. Any issues with that one? All right, you got it? Oh, perfect. That's what I wanted today. I really hope you just get no homework and don't get to practice this. That would be great. All right, let's go. Star. Clock. Curtains. Slide. Fade. Cube. Shatter. Flip. Genie. I like how people are voting for a lot of pinwheel. Page girl. Spin. Okay, it looks like we're going with shatter, everybody. Ready? Shatter or Promethean man again. Just going to be so bitter. Bless you. Shatter or Promethean man. Everyone ready? Ooh. Slide at it. Slide at it. All right, ready for the square? Who had slide? Listen to the man, right side? All right, listen to the man. All right, everyone ready? Square, inscribe. What's inscribe? Tell me again. Inscribe. Fill me in on the details. This square should be inside. Get more specific. Here you go. Square inside. Sure, you got it. Vertices touch the circle. All right, so I just want to lead up to what we're about to do instead of just showing you the steps. Got it. What do you know about the sides of a square? What do the sides of a square represent in the circle? Those are the what in the circle? Chords. If the chords are congruent, so are the. All right, so if you guys can somehow help me get 4 congruent arcs, you got a square. How can I divide a circle up into 4 congruent arcs? Let me make the task a little simpler. Can you do 2 congruent arcs? How? Draw on a what? Okay, go ahead. Grab your straight edge, draw on a diameter. You got 2 congruent arcs. Now we just got to talk how to make it into 4. How do I make that into 4, huh? Now that you see 2, how do you think I can break it into 4 now? Don't say draw another diameter because don't think so. Those aren't 4 congruent arcs. All right, Madeline, what's up? Got to bisect your diameter. Yes, make a perpendicular bisector for your diameter. Yep. So nothing new. A lot of these constructions we do this year are really based off of just 2 constructions, the perpendicular bisector and the perpendicular line. So open up your compass more than half the length of the diameter. Make a decent size arc. Keep the compass opening the same. Go to the other endpoint. And hopefully when you draw this line in, it should go through the center because you are drawing another diameter in. And then where's the square going to come from now? You got 4 congruent arcs up there. Now draw the chords now. Draw the chords that make those arcs. Go ahead. Ready? There's 1 chord. That's 1 arc. Congruent arcs have congruent chords. Oh, I'm not done with this one yet, honors kids. Are we all in agreement that all 4 sides are congruent up there in the square? That doesn't make it a square though. Just makes it a what? Anybody? If all 4 sides, it's at least a what? Rhombus. All right, what makes it into a square? A rhombus with a? Okay, somebody tell me why there's a 90-degree angle up there. Use a circle fact, please. Why is there a 90-degree angle up there? Because right now, okay, the sides being congruent, that's great. That just makes it into a rhombus. A rhombus with a right angle makes it into a square. What do you got, Carolyn? How do I know there's a right angle up there? There you go. In front of a diameter are right angles. So that guarantees now it's a square. Okay? All right, good. So we got a square. Look at that next one I'm asking you to do. Woo-hoo-hoo, hexagon. So based off of last construction, how many congruent arcs am I going to need here? Hexagon. 6 congruent arcs. 6? I know how to do 4. Are you kidding me with 6? Whew, how are we going to pull this one off? I'm going to show you how to do the construction, and at the end, I'm going to show you why it works. All right, so just let me show you the steps now, and then at the end, I'll prove to you why it works. Okay? Draw in a radius for me. Anywhere. Draw in a radius. Make a point somewhere on the circle right now. Make a point somewhere on the circle, and draw in a radius for me. Measure the length of the radius with your compass. Measure the length of the radius with your compass. And what you're going to do right now is you're going to go around the circle, making arc marks that are the length of your radius until you get 6 arcs. So I'm going to start up here, compass point up here. I'm going to go around the circle and just make a mark across the circle. That's the length of the radius. Then I'm going to go down here. Make another arc mark across the circle. That's the length of the radius. So every arc is the length of the radius right now. Keep going until you have 6 arcs. What? That's what I thought. Okay, just quickly let me prove to you why this works. Okay, quickly let me prove to you why this works. Don't draw any, please don't draw anything that I'm about to do on your diagram. What do you know about all radii? Sorry, what do you know about all radii in a circle? So those two are congruent, everyone agree? What was the length of this arc here? It was the same as your radius length, right? So if I draw this chord in, everyone now agrees that all 3 of those are congruent. What type of triangle is it? All 3 of these are congruent. Let's go. What type of triangle here? Equilateral. What do you know? You've known all year. What are the exact angle measures in any equilateral triangle? 60. What type of angle in the circle did I just label as 60? Central. What's a central angle always equal to? Arc measure. And if I keep doing this all the way around the triangle, do you see how I'll have 6 of them? And every time what's going to be the arc measure every time? 60, 60, 60. All right, so I've guaranteed that all the arcs are the same. So now go ahead. Now you can draw in your chords. I've already kind of done it, but draw in your chords and you will have a regular hexagon inscribed. And I know those chords are all congruent because I just proved to you guys all the arcs are 60 degrees. All right, all the arcs are 60 degrees. And I'm going to get rid of those radii now. So draw a radii and then get 6 congruent arcs from the radii. Questions from you guys, because we got one more, and I'm not going to say a word. How do you get an equilateral triangle in there? So what are you thinking? How many congruent arcs do I need? Okay, 3 congruent arcs. How many congruent arcs have I shown you already today? How to make 4 and how to make 6, okay. How do I get 3? You want to talk it over with your group a little bit? How do I get 3? Any group, come up with a way to get to 3. Go ahead, Andrew. How'd your group get to 3? Hold on 1 second. Let me get back to this because it's going to involve this construction we just did.
So with the finding the radius length and then doing like the 6 arcs, you do every other 2.
Correct, yeah. Because take a look, guys. When you do the hexagon, every arc was how many degrees? 60. So when you take 2 of them, it'll be what? 120, 120, 120. So yes, we're going to do the hexagon construction, but now we're not going to connect everyone. We're going to connect every other one. Nice job, guys. And equilateral triangle. Questions from you guys? Okay, I have a feeling most of you will finish the assignment since it's just 1 page in your packet. If you get done early, please do not pack up. Please start the review on the remaining pages, all right? The test review, quiz review on the remaining pages, please.